Welcome to day 2 of separation of variables. Yesterday's, or the first notes for this were pretty basic and simple. Today, this one, they get a little more complicated. You have to remember a little bit more of your algebra skills. All right, so I'm going to still separate my variables. So I have 1 over 1 minus y dy equals x dx. And I integrate. You need to do a u sub. So du is equal to negative dy. Make sure you have that negative. So this becomes negative integral of 1 over u du equals the integration of x dx. So that's the natural log. So negative natural log of 1 minus y equals x squared over 2 plus c. Alrighty. Get rid of that negative, so I have natural log of 1 minus y equals negative x squared over 2. And it doesn't matter if you have a plus or minus c. You'll take care of it when you do the math. Right? Now, to get rid of to solve for y, you've got to do e raised to those powers. Well, e raised to the ln of something is just 1 minus y. When you're adding exponents, it's the same as multiplying, so I have e to the negative x squared over 2 times e to the c. Well, e to the c, this is just a constant. So I can wrap it to the front. So I have 1 minus y equals c, e to the negative x squared over 2. And now you are going to move the 1 over and multiply by a negative. So you end up with y equals negative c e to the negative x squared over 2 plus, let's see, I subtracted 1 and I multiplied by a negative, so it's plus 1. Okay? This is tricky. You got to remember your algebra here. Okay? Right through here, you got to know how to deal with those exponents. So let's do another one. First place, I'm going to rewrite this. dy over dx, 1 plus x squared minus 2xy equals 0. So the first thing I'm going to do is move the 2xy to the other side. So I have dy dx, 1 plus x squared equals 2xy. And now separate. I want the y over here, so it ends up being 1 over y dy. And I'm going to move this over here, so you end up with 2x over 1 plus x squared dx. And then you integrate. This time my u is equal to 1 plus x squared. du equals 2x dx. So you integrate 1 over y dy equals 1 over u du. So you get the natural log of y equals the natural log of u, which was 1x squared, plus c. When you take e to both sides, this becomes y. You end up this, and you end up with times this, correct? Dang it. E to the c. You multiply them. So that becomes just c, and this becomes 1 plus x squared. Alrighty? Pretty tricky. Okay. We'll do this one, and I'll give you the answer to that one. Okay? So this ends up being 1 over y squared dy equals x dx. Be careful, this is not the natural log of y squared. Right? This is the integration of y to the negative 2 dy. Integration of x dx. And so that becomes negative 1 over y equals x squared over 2 plus c. You multiply by the negative. And then you take the reciprocal. Okay, the answer to this one is y equals c e to the x cubed over 3 minus 1. So So make sure you see if you can get that answer. All right, this time they give us initial conditions. This one gets messy, and this should have been a y squared, not a y2, okay? So fix that. So when I separate them, the first thing I got to do is move this to the other side. So you end up with xy dx equals negative e to the negative x squared times y squared minus 1 dy. And you bring this over here, so you add that. No, you're going to divide that. So you end up with x divided by negative e to the negative x squared dx. And then you end up with y squared minus 1 over y dy. And I got to integrate. Well, this turns into the integration of y minus 1 over y. This is the integration of negative x e to the x squared, right? A negative exponent in the denominator. So this becomes y squared over 2 plus ln of y. This, u is equal to x squared, so du is equal to 2x dx. So you get a negative 1/2 out front of e to the u du. So we already integrated that. This ends up being negative 1/2 e to the u plus c equals y squared over 2 plus ln of y. And now I'm going to put in my initial condition. Y equals 0. No, x equals 0. Y equals 1. Oh, we didn't put our x back in, so hang on. Let's put our x back in. So if x is 0, this becomes negative 1/2 plus c. This becomes 1/2 plus ln of 1. The ln of 1 is 0. So c ends up being 1. You end up with y squared over 2 plus ln of y equals negative 1/2 e to the x squared plus 1. And I don't solve that for y. We just left it that way. How do you know? Because I don't know how to solve for y. So that's why I left. Okay? This one, I'm going to give you the answer. So y is equal to 3e to the 1 minus 1 over x. This one I'll work. Okay? So I get 1 over y dy equals 4x cubed dx. Integrate. Natural log of y equals x to the 4th plus c. Plug in your initial conditions, 0 and 8. Actually, I did not plug them in here. I went ahead and took it e to a power. So you end up with y equals e to the x to the 4th plus c, which is c e to the x4. And now I plugged in my initial conditions. 8 is equal to c times e to the 0. So c is equal to 8. And I get y equals 8 e to the x to the 4th. All right, you need to understand what's going on right here, why that goes to here, okay? Because remember, this is the same as e to the x to the 4th times e to the c, because you add exponents. And e to the c is just a constant. Okay? All right, a real actual application problem. At the beginning of 2010, a landfill contained 1,400 tons of solid waste. The increasing function W models the total amount of solid waste stored in the landfill. Planners estimate that W will satisfy the differential equation for the next 20 years. W is measured in tons and T is measured in years. So it's tons of waste per year. If I integrate it, I get tons, correct? All right. One thing I'm going to warn you about before I work this is some people like to distribute this. So you get TW over DT equals W over 25 minus 12. And then they add that 12 over here, and you end up with, well, you bring the dt over, so you have W over 25 minus 12 times dt, or they want to subtract this and bring it over there first, so you have dW over dt minus W over 25 equals negative 12, and then you just don't know what to do, because if you multiply by dt, so don't do this, all right? You can't move things when they're added and subtracted. These are products, so it's easy to separate them. So I'm going to bring this over here, so I get 1 over W minus 300 dW equals 1 over 25 dt. And I leave the constant with the x or what, t. Okay, now U is equal to W minus 300. du equals dW. So I have the integration of 1 over U du equals 1 over 25, the integration of dt. Natural log of U, which is W minus 300, equals 1 over 25 times t plus c. Well, I have initial conditions right here, so I plug in 0 for time and 1400 for W, so you get the natural log of 1400 minus 300 is equal to 0 plus c. So c equals a natural log of 1100. All right, so come back to my equation. ln of W minus 300 equals t over 25 plus the natural log of ln of 100. E to the power, e to the power. This becomes W minus 300. This becomes 1100 e to the t over 25. So you just add 300 to both sides. And you're done. Okay? And that'll give you how many tons you get. That's a typical AP question. All right. Here's one with a slope field in it. They give us a differential equation. This is what I was telling you the other day, is that they love slope fields and differential equations because you can ask several questions dealing with the same thing. So it starts out, sketch a slope field. Well, if x is 0, the whole thing's 0. If y is 0, the whole thing's 0. So that took care of a lot of the dots. If you have 1 and 1, it's negative 1/2, so that's kind of laying down. If it's 1 and 2, that's negative 4 over 2, which is negative 2, which is a little steeper. Right, it's negative, is that right? Negative, yes. And here I have got 2, so it's negative 2 times 1. So negative 2 over 2 is negative 1. And I have 2 and 2, so 2 squared is 4 times 2 is 8, and it's negative, so that's negative 4, so that one's really steep. Negative 1, so this becomes 1 times 1, so that's a half, so that's this way. And you put this, so you have 1 times 4 is 4, over that is 2, so that's this way. And then you're done. Took care of that part. Okay? Write an equation for the tangent line to the graph at x equals negative 1. Okay, well, they gave us these initial conditions, so we know it's y minus 2 equals x minus a negative 1. All we need is the slope. Well, you just plug them in. dy dx equals negative 1 times 2 squared over 2. So that equals positive 2. Okay? So that's a 2. And now you go and plug in 1.2 equals 2 times 1.2 plus 1. So that's 2 times 2.2 is 4.4. And then I'm going to add 2, and I get 6.4. Okay, so that's worth a couple points. Finding your slope's worth a couple points. Writing the equation's worth a couple points. Probably that's a 3-point problem. Okay, find the solution to y equals f of x for the differential equation with the initial conditions. So I have to integrate that. So I'm going to bring the y squared over. So I have 1 over y squared dy equals negative x over 2 dx. And I'm going to integrate. This becomes negative 1 over y. You got a negative 1/2 out front, so it becomes negative x squared over 4 plus c. Use your initial condition. So I have negative 1 over 2 equals negative 1/4 plus c. So you add a fourth, so you get c equals a negative 1/4. So negative 1 over y equals negative x squared over 4 minus a fourth, multiplied by a negative, and then you take the reciprocal, so you flip it over, and you get 4 over x squared plus 4. Booyah, done. All right. Good luck on the worksheet. Practice, practice, practice. Y'all, you can't wait till test day to learn this. Thanks.